Hello, I welcome you all for this session on instruction set of PIC16F877. This PIC16F877 is a microcontroller which has 35 instructions. Each instruction is 14-bit in width. And since it has less number of instructions, it follows RISC architecture, that is reduced instruction set computing architecture. Before entering into the instruction set, let us have a brief introduction about the difference between the microprocessors and microcontrollers. So microprocessors, the functional blocks or ALU, registers, timing and control units. It do not include memory in it, but microcontrollers includes memory in it. And then bit handling instructions are very less in the case of microprocessors, but microcontrollers has many special bit handling instructions. Rapid movement of code and data between the external memory takes place because it do not have much internal memory. It has only registers. In the case of microcontrollers, it has internal memories. So the movement of code and data will be between the memories. Similarly, microprocessors are commonly used for digital computers and microcontrollers are used for all special purpose applications. Another thing which we need to know is von Neumann and Harvard architecture. There are two types of architectures, many architectures. Two commonly known are von Neumann and Harvard architecture. So what is Harvard architecture and von Neumann architecture? The diagram clearly explains the difference between these two. So it has CPU. In both the cases, it is having CPU. Here, in the case of Harvard architecture, the program and data memories are separated. For program, we have separate memory. For data, we have separate memory. But in the case of von Neumann architecture, the program and data memory are the same. So because of this, once an instruction is being fetched from the memory, parallel data processing cannot be done because data and address shares the same common memory. But in the case of Harvard architecture, since program is available in a separate memory and data is available in another memory, when one instruction is being fetched, another instruction can be executed. So Harvard architecture increases the speed of processing too, and this PIC16F877 follows Harvard architecture. Next, coming to RISC and CISC computing. As I said, PIC16F877 has only 35 instructions. It means that it has RISC architecture, that is reduced instruction set computing architecture. It has hardware control. It executes one instruction in one cycle. That is, the speed will be very high. And the instructions are simple formats, and the number of addressing modes are also very less. These are few points or advantages and disadvantages between RISC and CISC computing. Now let us look into the instruction set of PIC16F877. When we see the instruction set, altogether we have 35 instructions. So if you count all these instructions, totally you'll be having 35 instructions. Among these, the 35 instructions are categorized into 6 sets, that is instruction sets. So one is move instruction, second one is register, third one is arithmetic instruction set, then logical instruction set, test, skip and jump instruction set, and control instruction set. So move instruction set, it has move F. Here F denotes the file register, or move WF. W denotes the working register and F denotes the file register. So similarly, every processing or the number of operations are combined together in a RISC computing architecture, or in PIC16F877, more number of operations are integrated in a single instruction. So we can, if we see for arithmetic, 4 instructions are there. For control instruction, 3 instructions are there. That is, one is no operation instruction, one is sleep instruction, another one is clear watchdog timer instructions. So we have all these instructions which are included under 6 instruction sets. So how this opcode field looks. So as we see that it is 14-bit in wide. This 14 bits includes the file register, the working register, the bit address register. If it is literals, that is the PIC instructions can also be categorized into bit instructions, byte instructions, and literal instruction. That is, immediate data can also be given. So that everything will be mentioned here, and D is where the destination is, where it has to be stored. Once after execution, whether the output has to be stored in the W register or in the file register. That is also mentioned here. So the opcode 14 bits includes all these datas inside. So as I said, basic categories are bit-oriented instructions, byte-oriented instructions, literals, and control operations. Byte-oriented instructions is as bytes, the operations will be taking place. And in bit-oriented instructions, single bit can be modified using bit-oriented instructions. And literals or direct constants will be used in the instruction. So this is how it looks for the 3 types. If it is byte-oriented instruction, we have the file register here, the datas, and this D denotes the destination where the result has to be stored. It could be stored either in the working register or in the file register. So this D denotes that. If D is equal to 0, then the result will be stored in the working register. If D is equal to 1, the result will be stored in the file register. If it is not mentioned, as a default case, the result will be stored in the file register. And then bit oriented instruction. So how the 14 bits, how many bits opcodes occupy, how many bits is required for file register, how many bits is required for storing the data. And here the literals for opcode and for the literal or the immediate data. So for these are the byte oriented instructions. So here we have the add, and that is arithmetic operations, logical operations, complement operations, clear operation, decrement, increment, no operation, rotate operations, swapping operations. All these are byte operations, and this denotes when these byte operations are executed, which are the flags gets affected. So this is the carry flag, direction flag, and 0 flag. So Z denotes a 0 flag. So for example, when complement F is executed, the 0 flag also will get either set or reset depending on the operation. So if you see SUBWS, that is subtract working register with the file register, when this instruction is executed, obviously all these 3 flags gets affected. So we have to check all these 3 flags. These are the bit-oriented instruction. As we said here, 4 more than enough is available. Bit-oriented instructions, which is used to clear a particular bit in any of the register, which is used to set and also it is used to clear or set based on different conditions too. And next comes the literals. And in the case of literals, direct data we'll be mentioning. So these are the literals, and these are the flags which gets affected when these literal operations are executed. So now we have completed the session on instruction set of PIC16F877. So I hope you have understood it, and so you can take this assessment for yourself. Thank you.